Okay, so this question is asking us to explain how we do the halogen displacement reactions. So I've drafted my answer here. I'm going to take you through it to see how I would structure this particular response. So first of all, in terms of completing these reactions, we're going to use these solutions. We're going to react with the solutions of the halogens as well. So to show people I'm going to do that, I've made the table. And again, this should be something you're familiar with seeing from when we did this in class. Here are my salt solutions, and then here are my halogen solutions. And you can see what we're going to try and do is react the halogen solution with each of the salts. But what we don't do is react, say, the chlorine with the chloride and the bromine with the bromide. And we'll do the last one, iodine with the iodide, because they're the same halogen in each one. There's no point doing that. So we start with 3 big red crosses to show that we're not going to do those reactions. So putting that into words, we say that we react each salt solution with each halogen, and there's no need to react a halogen with its own salt solution. Then, if we have a look at sodium chloride, chlorine is the most reactive of the halogens in the 3 that we've got. So these 2 are not reactive enough to react at all. So we've got 2 crosses there. And to reflect that, all I've said is that sodium chloride will not react because the chloride ions are the most reactive. Working our way down, sodium bromide. The iodine will not react. So the sodium bromide not reactive iodine because the bromide ions are more reactive than the iodine itself. Sodium bromide will react with chlorine because the chlorine is more reactive than the bromine. And to show that, here you can see I'm then given the equation. So I've got my chlorine reacting with my sodium bromide. And what's going to happen here is the chlorine displaces the bromine. So we form sodium chloride, and there is the bromine that's been pushed out because it is less reactive. Because the bromine's there, this means the solution turns orange because bromine is an orange color. And we say that's happened because the bromine is being displaced or pushed out from this compound. So the tick, and here we've got sodium bromide is a tick with the chlorine and a cross with the iodine. And then sodium iodide, the final one, this is going to react with both of these 2 because this is the least reactive. So here we've got that sodium iodide react with both the chlorine and the bromine. That means that chlorine and bromine are more reactive than the iodine. The reaction for the chlorine is that, again, this is going to displace the iodine to form sodium chloride. And because iodine is displaced, the solution is going to turn brown. And the same thing happens here with the bromine. The bromine displaces the iodine, and again, this solution will turn brown. So from all of this, what I can conclude is the reactivity order is chlorine is the most, then bromine, then iodine. So that's the final thing to include in your response.